In this video, I'm going to do more examples of how to graph the secant function. So in the last video, I remember when we graphed the secant function, we graphed the cosine function first, found the asymptotes where the cosine function crossed the vertical shift line, dashed in our cosine function, and then we were able to graph the secant function from our cosine function. So we're going to do the same thing here. So I'm going to go ahead and rewrite this function in terms of cosine. And I know in this function that my b value needs to be factored out. So I get, when I factor that out, I get 2 pi over 3. All right, so how am I going to use that to graph this function? Well, I'm going to calculate the period, which is going to be 2 pi over b. So I have a period of 4 pi. Okay, so now I'm going to find, I have a phase shift for my cosine function of negative pi over 3, because that's my d value. I have a reflection, right? I have a minus here, so it's being reflected upside down, reflected over the x-axis. And then I have also a vertical shift of 1 and an amplitude of the absolute value of -1, so my amplitude is also 1. Remember, secant does not have an amplitude, so how do these four things translate back into secant? Or 5 things, I should say, the same way, except I have no amplitude. So my period is going to be 4 pi. I have a phase shift of negative 2 pi over 3. So that'll be shifted left by 2 pi over 3. It is being reflected over the x-axis. I do have a vertical shift of 1, and there is no amplitude because our graph goes up to infinity and down to infinity. It is not bounded in any way on our x-axis. All right, so let's go ahead and find the beginning and the end for our cosine function. The beginning, I'm going to set that whole quantity, this whole thing, 1/2 x plus 2 pi over 3 equal to 0. Whoops, I don't need the bracket. Let's go ahead and set that equal to 0. When I multiply both sides by 2, I just get this. And then when I subtract 2 pi over 3, 2 pi over 3, my beginning is going to occur at negative 2 pi over 3. My end, I'm going to set this whole thing to 2 pi. When I multiply both sides by 2, I get this equals 4 pi. And then when I subtract 2 pi over 3 from 4 pi or 12 pi over 3, I get 10 pi over 3. And I do want to do 2 periods here. So if I count in terms of 2 pi over 3, between these two values, I have 6 counts, which won't leave me enough space because I would only have 5 counts going backwards to make another period, or I'd have to count another 6 counts going forwards. So I'm actually going to go ahead and divide each of these in half. And each one is going to represent a distance of 2 pi over 3. So this is going to be negative 2 pi over 3. So now I need to find 10 pi over 3. So 2, 4, 6, 8. This is going to be 10 pi over 3. So here's my first period. The halfway mark is going to be 4 pi over 3. And now you see that I only have 3 marks between negative 2 pi over 3 and 4 pi over 3. So I'm going to go ahead and further divide them. A mark here and a mark here. So when I add 4 pi and 10 pi, I get 14 pi over 3. Or when I divide by 2, I get 14 pi over 6, so that's 7 pi over 3. And when I do the same thing here, when I add these, I get 2 pi over 3, so that would be 2 pi over 6 when I divide it by 2, so that's just pi over 3. All right, so here's my first period. I am going to also label my second period. So I know I have to go back 1, 2, 3, 4, 5, 6 marks. 1, 2, 3, 4, 5, 6 marks. So I'm going to be right here for my end. And what is that going to be? That's going to be 1, 2, 3, 4, 5, 6, 7, negative 14 pi over 3. My mid mark is going to be here, 1, 2, 4, 6, 8, negative 8 pi over 3. Now I have to have these marks put in, and this is going to be 2, 4, 5 pi over 3, 8, 10, 11 pi over 3. All right, so now let's go ahead and graph the cosine function here. We have a vertical shift of 1, so I'm going to dash in my vertical shift line, and I'm going to label that as y equals 1. And then I have to remember that my cosine function is being reflected over the x-axis, so when I graph that in, it's going to be upside down. So I know at my quarter and 3/4 marks, my cosine is on my vertical shift. So I'm going to go ahead and mark those in. And then I know that on my beginning and end, since this is going to be flipped upside down, I'm going to be 1 down on both of those. So let's see, and over here. And my mid mark, I'm going to be 1 above my vertical shift. All right, so my cosine function looks like this. I have 2 nice periods graphed here. All right, so now I'm going to go ahead and dash in my my asymptotes. I'm going to use green for my asymptotes. Okay, so here we go. Wherever this graph crosses the vertical shift is where my asymptote will occur. So it's crossing at all of these spots, and remember I have to label my asymptotes. So this is x equals 7 pi over 3, x equals pi over 3, x equals 5 pi, negative 5 pi over 3, and x equals negative 11 pi over 3. So the last thing I just need to do is find my max and min values on my cosine function and draw in my loops. And remember, they approach our vertical asymptotes but don't touch it. My pen's a little thick, so I'm having a hard time making sure that they don't touch. But this is what my graph would look like. All right, so we have time for one more example. For those that want to see the last example, I added one because I was doing another video. So let's go ahead and graph our cosine function first. 2 plus 1/4 cosine, and remember, factor out that b value. Minus, when we factor that out, I'll get a 2 pi. Okay, so I know for this graph, I have an amplitude of 1/4. I have a vertical shift of 2. I know I have a phase shift of 2 pi. And then my period here is going to be 2 pi over 1/2, or 4 pi. Okay, so how does that translate to my secant function? Well, my secant function, there is no amplitude. No amplitude. I have a period that is the same as my cosine function. I have a vertical shift that is the same as my cosine function. I have a horizontal or phase shift that is the same as my cosine function. And I believe that's all we have right here. So there is no reflection over the x-axis for this graph. So let's go ahead and calculate the beginning and the end of my cosine function. So remember, I'm taking this whole value here and setting it equal to 0 and 2 pi to solve. When I multiply by 2, I get 0 on the right-hand side. When I add 2 pi, I get 2 pi. For my end, I get 1/2 x minus 2 pi equals 2 pi. When I multiply by 2, I get x minus 2 pi equals 4 pi. And then when I solve, I get x equals 6 pi. So that makes it really easy. I'm going from 2 pi to 6 pi, so I think what I'll do is I'll label every single mark on my x-axis with a distance of 2 pi. So I have 2 pi, or how about just a distance of pi? I have 6 marks, so I can use pi. Pi, 2 pi, 3 pi, 4 pi, 5 pi, and 6 pi. All right, so I have my begin and end. I want to do 2 periods, so I'm going to go backwards from 2 to 6. 1, 2, 3, 4. I have 4 jumps, so I'm going to go backwards 4 jumps. 1, 2, this is 0. 3, negative pi. 4, negative 2 pi. All right. So now I need to go ahead and I think I have a vertical shift of 2. I'm going to go ahead and draw that in, my vertical shift of 2, and label that line. And now I am going to go ahead and plot points for my cosine function. So I know my cosine function is going to look like, let's see, I know at the beginning of the quarter and 3/4 marks, I'm on my vertical shift. So my quarter mark and my 3/4 mark, I am on my vertical shift. So these are my quarter and 3/4 marks. All right, so at my begin and my end, I am above by my amplitude. So I'm not above by much because my amplitude is 1/4. And then midway through, I'm below by the same amount, by 1/4. So I'm just going to go ahead and dash my graph in. All right, so now I'm going to draw my asymptotes wherever my graph crosses my vertical shift, and I'm going to make sure that I label them. All right, when I'm done with that, let's label x equals 5 pi, x equals 3 pi, x equals pi, x equals negative pi. Okay, last step. I'm gonna go ahead and graph in my little parabola looking things approaching my vertical asymptotes. Okay, the important point on this graph, this is the important point and the asymptotes. So make sure you graph those correctly. And that's my last example for secant.